let's begin with a new topic, and that is nitric acid. Nitric acid initially was known as AQUA. It was in 8th century alchemist called nitric acid as AQUA. Reason for that, it was a very strong water which was very corrosive in nature. This nitric acid can occur in both the form, free state as well as combined form, which we will be discussing in this topic later on. Nitric acid, you must have learned about it in your lower standard in the process of fixation of nitrogen. This nitric acid has a large amount of application in our day-to-day life, like purification of gold. You wear so many ornaments made up of gold. Do you know that? To purify this gold, we use nitric acid in the form of AQUA REGIA. Similar manner, this nitric acid is also used as a rocket fuel. So now let's learn about this nitric acid in detail. As I told you, it has a free existing. Now let us see how it exists in a free state. Nitrogen in the atmosphere combines with oxygen during lightning and thundering to form nitric oxide, that is N2 plus O2 during lightning and thundering will form 2NO nitric oxide. This nitric oxide further gets oxidized to nitrogen dioxide, that is 2NO plus O2 will give you 2NO2. This nitrogen dioxide then combines with moisture in the air along with oxygen to form nitric acid, which falls down on the surface of the earth and forms soluble nitrate. The reaction goes like this. 4NO2 will combine with 2H2O plus O2 giving you 4HNO3, which combines with salts like calcium carbonate, that is CaCO3, to give soluble nitrates, that is Ca bracket NO3 twice, along with water, H2O and carbon dioxide, that is CO2. Not only that, it also occurs in the combined form like chili saltpetre. Chili saltpetre is the other name for sodium nitrate, that is NaNO3, and also in the form of Bengal saltpetre. Bengal saltpetre is nothing else but potassium nitrate, KNO3, which is also known as niter. Now we are going to see how to prepare nitric acid. Nitric acid can be prepared in two ways. One, in lab method, and on a larger scale in industries by the process called Ostwald process. Let's start with the lab method. In the laboratory, first and foremost thing, you have to take a glass apparatus, a glass retort. The whole apparatus has to be made up of only glass. Reason? Nitric acid vapors which will be formed is highly corrosive in action. It can attack rubber, wood, etc. So we should not use any instrument or any material made up of rubber or wood. Reason, as I told you, it is highly corrosive in nature. So let's begin with the preparation part of it. First and foremost thing, the chemicals which we are going to take in order to prepare nitric acids are: nitric acid can be prepared by potassium nitrate, which is known as niter, or sodium nitrate, which is known as chili saltpetre. We can take any one of them and treat it with concentrated sulfuric acid in the ratio of 1:1. Now why should we select only sulfuric acid? Why not HCl? Reason for that is sulfuric acid. It is a non-volatile acid which can remove the nitrate from its salt. Similar manner, we cannot use hydrochloric acid because it is a volatile acid. So we have no other option but to go with concentrated sulfuric acid. Okay, so when the reaction takes place, when we heat it, we get an acidic salt, that is potassium bisulfate, along with vapors of nitric acid. But you have to be careful. We have to keep the temperature always below 200. If you don't keep the temperature below 200, there will be a problem. First and foremost thing, it will damage the whole apparatus. Secondly, this nitric acid, it decomposes at a very high temperature. Even at ordinary temperature it decomposes, but to a lesser extent. And thirdly, it will form a hard crust surrounding the round bottom flask or the retort which you have taken it. So we have to always keep the temperature below 200. Now these vapors which comes out will be collected in a receiver. This receiver is cooled by putting water on it, as a result of which we get liquid nitric acid, condensed form of it. The reaction will go like this. It is KNO3 plus H2SO4 concentrated. Keep the temperature below 200. We get KHSO4, that is potassium bisulfate, along with HNO3 vapors, that is of nitric acid. If we use sodium nitrate, the reaction will be NaNO3 plus H2SO4 concentrated. Keep the temperature below 200. We'll get NaHSO4, that is sodium bisulfate, along with vapors of nitric acid, that is HNO3. If we take the temperature above 200, then the corresponding metal sulfate salts will be formed, which is a poor conductor, and it will stick to the wall of the glass apparatus and it will damage the apparatus. The reaction goes like this. NaNO3 will combine with NaHSO4, giving you Na2SO4 plus HNO3 if the temperature is above 200 degrees Celsius. Now this nitric acid which you get it in the lab, you find the color to be yellowish brown. The reason for that is the decomposition of nitric acid taking place. In pure form, nitric acid is colorless. But this yellow tinge which you see, the yellowish brown color, is because of the decomposition, as I told you. That is, HNO3 will break down to give you water, H2O, NO2 and O2. This NO2 you can remove it also. You can go for dilution, which can dilute NO2. NO2 is highly soluble, so it dissolves in it. Or you can pass carbon dioxide, which will oxidize NO2 to HNO3. So let's begin with the industrial method. In the industrial method, we are going to go for Ostwald process. Ostwald process is carried out in 3 chambers. To begin with it, first is the catalytic chamber, second oxidation chamber, and the last absorption tower. In the catalytic chamber, we have packed the whole chamber with platinum, which will be used as a catalyst. The temperature maintained in this case will be 800 degrees Celsius. Reason? It's an exothermic reaction which is going to take place inside. So only initial heating is required. The reactant which we are going to select is ammonia and oxygen in the ratio of 1:10. Now why such a large amount of oxygen? Reason? We are going to use this oxygen in all the 3 chambers. The reaction which takes place in catalytic chamber is ammonia, that is 4NH3, will combine with oxygen, that is 5O2 in presence of platinum at a temperature of 700 to 800 degree Celsius. It will form nitric oxide, that is 4NO plus 6H2O. Along with that, it will evolve heat of 21.5 kilocalories. Now this NO along with moisture, along with unreacted oxygen, is allowed to pass through a cooling pipe, and then it will enter into the second chamber, and that is oxidation chamber. In oxidation chamber, nitric oxide is further oxidized to form nitrogen dioxide. But this time you have to be careful. Keep the temperature around 50 degrees Celsius. If you keep a temperature above 50 degrees Celsius, then are possibilities that NO might decompose. So the reaction taking place in oxidation chamber is 2NO plus O2 at a temperature of 50 degrees Celsius forms 2NO2. Now this NO2 gas, that is nitrogen dioxide, enters into the last chamber, that is absorption tower. This absorption tower is packed with cords. Generally this absorption tower can be made up of steel, that is an alloy of iron, and it is inside packed with cords. Reason: nitric acid which will be obtained is highly corrosive in nature. So we have packed the whole apparatus with cords. NO2 which enters in the absorption tower combines with moisture. Some amount of water is sprinkled from the top also, and in presence of oxygen it forms nitric acid. The reaction goes like this: 4NO2 plus 2H2O plus O2 will form 4HNO3. This nitric acid which is obtained, it is 50% concentrated. You can go on concentrating up to 68%. It becomes a constant boiling mixture at a temperature of 121 degrees Celsius. You already know what is a constant boiling mixture. A constant boiling mixture is a mixture which beyond the certain limit cannot be further concentrated, because if you try to do it, it will evaporate equal amount of water and equal amount of acid. So the composition remains same. But in this case, you can further concentrate up to 98% by using concentrated sulfuric acid and reducing the pressure. It can go up till 98%, which we call it as fuming nitric acid. Okay student, now let us start with the chemical properties of nitric acid. Nitric acid is an unstable compound even at room temperature. This nitric acid, it decomposes to give you NO2, that is nitrogen dioxide, water, that is H2O, and oxygen. This nitrogen dioxide, which is released, gives a yellowish brown color to the solution. And you know how to overcome this problem? Either you pass carbon dioxide gas through it or dilute it with excess of water. This nitric acid shows a color change with respect to various indicators, like you take moist litmus paper, it will turn blue to red. Secondly, you can take methyl orange, which turns orange to pink. At the same time, if you take phenolphthalein, it remains colorless in spite of putting nitric acid on it. Nitric acid is a monobasic acid. What do you mean by monobasic acid? Whenever you put nitric acid in water, it decomposes or undergoes ionization, that is formation of ions. It forms two ions, that is hydronium ion and nitrate ions, which indicates the acidic properties of it. Nitric acid reacts with a base, giving the metal nitrate along with water. The reaction goes like this. You take NaOH, a very strong alkali, a base, treat it with dilute nitric acid. It will give you sodium nitrate, NaNO3, along with water, that is H2O. And you know how you have to do it? Secondly, it can also react with carbonate of a metal, like calcium carbonate, CaCO3, reacts with nitric acid, HNO3, giving you calcium nitrate, CaNO3 twice, along with water and also carbon dioxide gas. Not only that, it can also react with metal bisulfite, like calcium bisulfite, Ca bracket HSO3 bracket close twice, reacts with nitric acid, HNO3, giving you calcium nitrate, that is CaNO3 twice, plus H2O plus SO2 gas. Nitric acid is a very strong oxidizing agent. Now why? Reason for that is nitric acid, it decomposes to give you water, NO2, and release nascent oxygen. This nascent oxygen has the capacity of oxidizing a non-metal, a metal, inorganic compound, as well as organic compound. Let us take few examples and understand this. To begin with it, with respect to non-metals like carbon, sulfur, phosphorus, hot and concentrated nitric acid will react with it. Let's see the reaction part of it. Carbon reacts with nitric acid, giving you carbon dioxide, water, and NO2 gas. Similar manner, it can react with other non-metals like sulfur, phosphorus, again treated with nitric acid, giving you sulfuric acid, water, and nitrogen dioxide in case of treatment of nitric acid with sulfur. Whereas with respect to phosphorus, it will give you phosphoric acid, that is H3PO4, along with water, along with NO2 gas. Similar manner, we can select dilute nitric acid and treat it with metals. Now let us consider an example where we are going to take a very dilute nitric acid. To begin with it, we take magnesium and we treat it with cold, very dilute nitric acid. It will give you magnesium nitrate, MgNO3 twice, along with hydrogen gas. Now the question is, why is it not giving you water? A reason for that, since you have taken very dilute nitric acid, it will not release nascent oxygen. So the hydrogen which is liberated is not oxidized to water. Similar manner, you can select one more example, and that is manganese, Mn. Mn treated with a very dilute cold nitric acid will give you MnNO3 twice, that is manganese nitrate, along with hydrogen gas. Now let us consider only a dilute one, not very dilute nitric acid. To begin with it, let's select few metals like copper, zinc and iron. To begin with, let's take copper. Copper treated with dilute nitric acid will give you copper nitrate, that is CuNO3 twice, plus water plus NO, that is nitric oxide. If you take zinc treated with nitric acid, HNO3 will give you zinc nitrate, ZnNO3 twice, plus H2O plus NO. Similar manner, if you take iron, that is Fe plus HNO3 will give you ferrous nitrate, that is FeNO3 twice, along with water, along with NO, nitric oxide. Let's see the reaction of hot concentrated nitric acid with the same metals. To begin with, first we'll take copper. Copper treated with nitric acid, hot concentrated, will give you copper nitrate, that is CuNO3 twice, along with water and NO2 gas. In the previous case, we had got NO, that is nitric oxide gas. But in this case, we are getting NO2, that is nitrogen dioxide. Similar manner, we can select the same metals again, that is zinc treated with concentrated hot nitric acid will give you zinc nitrate plus water plus NO2 gas. Again we take the same metal, that is iron, treated with nitric acid, that is hot and concentrated nitric acid, but this time you will get ferric nitrate, that is FeNO3 thrice plus H2O plus NO2 gas. Pure nitric acid renders aluminium and iron passive. What do you mean by passive? It becomes non-reactive. Reason: this nitric acid, concentrated fuming nitric acid. You know what is fuming nitric acid? 98% concentrated nitric acid is called fuming nitric acid. It forms a thin oxide layer on the surface of the metal. As a result, the metal becomes inactive. This is what is called passive. You can remove this. After that, the metal can become reactive again. Nitric acid plays a very important role in the formation of AQUA regia. You know what is AQUA regia? It is that chemical which can dissolve noble metals like gold and platinum. How is it formed? You take 3 parts of HCl and 1 part of HNO3. That means combine both the concentrated acid in the ratio of 3:1. That is 3 HCl plus HNO3 will give you nitrosyl chloride, that is NOCl, along with water, along with nascent chlorine. Nascent has to be written in a bracket, so you will get Cl in bracket. This will react with gold, Au, combining with nascent chlorine will give you AuCl3. Similar manner, platinum will combine with nascent chlorine, giving you PtCl4. Now this nitric acid can also oxidize inorganic compounds. So now let us consider some inorganic compounds like SO2 gas. Along with that, we can take hydrogen sulfide. Not only that, we can also select ferrous sulfate. To begin with it, let's take sulfur dioxide. In this case, this reaction will be possible in presence of water. So, SO2 plus H2O along with dilute nitric acid will give you H2SO4 plus nitric oxide. That is, whenever you take nitric acid in the dilute form, you will get nitric oxide. Similar manner, you can select H2S, that is hydrogen sulfide. Hydrogen sulfide has a rotten egg smell. Take hydrogen sulfide and treat it with nitric acid. It will give you colloidal sulfur S along with nitric oxide along with water. Then you take ferrous sulfate. It has to be acidified. What do you mean by acidified? Add acid to it. So FeSO4 along with H2SO4 along with nitric acid HNO3 will form ferric sulfate, that is Fe2SO4 thrice, along with water, along with NO. Don't forget to balance the equation. Similar manner, hot and concentrated nitric acid can also oxidize organic compounds like sawdust. Sawdust, which has a formula of C6H10O5. Close the bracket and put N. It oxidizes sawdust to give you water, carbon dioxide and nitrogen dioxide. Not only that, it forms an explosive chemicals when it is treated with toluene. Toluene has a formula C7H8. Treated with nitric acid, it will give you C7H5 bracket NO2 thrice, which is called TNT. TNT stands for trinitrotoluene, an explosive chemical. Along with that, you get water.